Hello, 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 everybody. Welcome back. This is the review video for Unit 2. So, in the last few videos of this topic, there are only 3 lesson videos. We talked about history of the periodic table, parts of the periodic table, and the periodic table trends. And again, in this video, we're going to go over the Unit 2 practice test. So, question number 1. The elements on the periodic table of the elements are arranged in order of increasing. So here is just kind of a you need to know. It is atomic number. Remember, atomic number is the same as the number of protons, and it is specific to each element. One of the previous models of the periodic table was going by mass, and if you look carefully, most of the masses do increase, but isotopes exist, so mass is not the perfect way about doing this. Atomic number is what we do today. Question number 2, which element consists of a metal, metalloid, and nonmetal? So here is your periodic table. Remember, your metalloids are the staircase. So metalloids, anything to the left, all of these are your metals. And anything to the right of the staircase are your nonmetals. So if you were to look at this in more detail, again, without your periodic table, this could be kind of hard. Li is a metal, Na is a metal, Rb is a metal. So, can't be A. If you look at B, Cr is a metal. Mo is, if you look for it somewhere, I am looking for it, here you go, is a metal. And W is also a metal. So it can't be that one. If we look at choice C, Sn, which is tin, is a metal. And then Si is a metalloid. And carbon, C, is your nonmetal. So remember the metalloids that you need to know are boron, silicon, germanium, arsenic, Sb, Te, and Po. Okay. And if we look at choice D, these don't work, so your answer has to be C. Okay. Number 3 says which list includes elements with the most similar chemical properties. So these are elements that have to be in the same group or column. So the answer to this would be C, O, S, and Se. All of these are in group 16. So everything in the same group, they react similarly, they have similar chemical properties because they have the same number of valence electrons. So anything in group 16 has 6 valence electrons. They only want 2 more to fill in that full valence shell. So they'll do similar things to get those last 2. So same group, so same up and down column. Number 4 says the chemical properties of calcium, which is Ca, is most similar to the chemical properties of, again, you want to be in the same group or the same column. So calcium lives in group 2. Argon is group 18, can't be argon. Potassium, which is K, lives in group 1, can't be B. Magnesium, Mg, lives in group 2. Looks pretty good, so let's just double check that last one. Sc, scandium, lives in group 3. Can't be that. Has to be magnesium. Again, same group, similar chemical properties because they have the same number of valence electrons. Number 5 says which trends are observed when elements in period 3 on the periodic table are considered in order of increasing atomic number. So it's basically saying as you go left to right, what happens? So with this, the question is talking about atomic radius and ionization energy. So whenever you're thinking about atomic radius, you should think of that snowman. And so as you get big, as you go down, AR will actually increase. And with your snowman nose, as you go across, AR, or the atomic radius, decreases. So as we're going from left to right, we want atomic radius to decrease. So we can get rid of answer choices C and D. And then if we're talking about ionization energy follows the same trend as electronegativity. And remember, with electronegativity, F is the most electronegative. So the closer you get to F, the electronegativity and the ionization energy, they both increase. So that means the answer has to be. So again, if you remember the atomic radius snowman, and that fluorine is the most electronegative atom, the closer you get to it, the higher electronegativity goes, and that ionization energy has the same trend as electronegativity. That's basically what you need to know. If you forget all of that, that is okay. Do not freak out and panic. You can look at table S. They have the values for atomic radius, ionization energy, and electronegativity. So you could pick a few elements across period 3 or whatever the question is asking about and look at those numbers and then kind of come to the same conclusion. Memorizing the trends just speed up these questions. Okay. Okay, so moving on, number 6 says a sample of an element is malleable and can conduct electricity. This element could be. So malleable and being a conductor, those are properties of metals. Oops. Properties of metals. So if we're looking at this, H is a nonmetal. Even though it's in group 1, that's just there because it fits nicely there. H is a nonmetal. Helium is a nonmetal. S, which is sulfur, is a nonmetal. And so your only option is tin, which is D, and that is a metal. Number 7, just get rid of that scribble, says what 2 characteristics are associated with metals. So remember, your metals, here's your staircase, is everything over there. So, and then it's talking about ionization energy and electronegativity. So ionization energy and electronegativity, they do the same thing. And again, if we know that fluorine is the most electronegative, the closer we get there, electronegativity and ionization energy increase. So if fluorine has the most electronegativity value, the highest electronegativity value rather, and the highest ionization energy, that means for metals, the electronegativity and the ionization energy are both low. So we want low ionization energy and low electronegativity. So both of them are low. Again, these two things do exactly the same thing. And again, if you forgot that pattern or that trend, you could have looked at table S, looked at a few metals, at the ionization and electronegativity value, compared that to a few nonmetals, and then came to the same conclusion. Okay, moving forward, number 8 says at STP which element is solid, brittle, and a poor conductor of electricity. So, I don't know if we mentioned this yet. STP means standard temperature and pressure for every unit except for gases, which is still a whiles away. You can ignore it. It's there just to confuse you. So it says element solid, brittle, poor conductor of electricity. So all of these things shout non-metal. So if we're looking at these antitraces, we have aluminum, which is a metal. We have K potassium, which is a metal. We have neon, which is a non-metal. And then we have sulfur, which is a nonmetal. Then we run into the problem, well, we have to pick one answer, but there are two of them. So the key word here is solid. Remember, neon is a gas. It's a noble gas in group 18. So neon is that gas, meaning the only solid here is sulfur, which is choice D. Number 9 says which elements tend not to react with other elements. So remember, elements are bonding with other elements to form that full, stable, valence shell. The only elements that don't do that already have a full valence shell, and those, again, are your noble gases, which is group 18. Now, your answer choices doesn't say noble gases, but helium is one of those noble gases. Remember, noble gases think they're better than everybody because they have that full valence shell, so they don't need to interact with any other elements. They're good on their own. Okay. Number 10 says pure silicon is chemically classified as a metalloid because silicon. So again, if we're talking about metalloids, here's your periodic table. Metalloids are that staircase. So they're not quite metals, they're not quite nonmetals. The definition of a metalloid, and this is kind of super important, is that it exhibits both metal and metallic and non-metallic properties. So generally they look like metals or have physical properties as metals, and most of them have chemical properties of nonmetals. So they act like nonmetals. Look like one, act like the other. Either way, they have both metallic and non-metallic properties. That's what makes something a metalloid. A kind of in-between object. It's in between the metals and the nonmetals, so they act kind of like an in-between object. Okay, moving forward, our next question, number 11, which salt contains an ion that forms a colored solution. So right off the bat, you're probably like, how am I supposed to know this? And the keyword here is colored solution. So things that form colored solutions, that is a characteristic of something that has transition metals in it. Remember, that's grouped 3 all the way through 12. So if this is your periodic table, here are your metalloids, that staircase, your transition metals are that middle section. So if we're looking at these 4 answer choices, they all have NO3 in common. So it can't be that. We have to look for which first part of that compound is a transition metal. So Mg, that is in group 2, that's an alkali earth metal, can't be A. Ca is calcium, that is also an alkali earth metal in group 2, can't be B. Nickel is in group 10, that's in between groups 3 and 12, so it could be C. Let's just double check with D. D, aluminum is in group 13. 13 is not, it's nearby, but is not a transition metal, so it cannot be D. So the answer has to be C, nickel. Or nickel nitride, I should say, rather. Okay, number 12 says which term represents the strength of the attraction of an atom, strength of attraction an atom has for electrons in a chemical bond. So if we're talking about the attraction for electrons, that is a super duper important definition of electronegativity. So the only really other option that we've talked about that deals with electrons is ionization energy. But remember, ionization energy is the energy needed to remove an electron, not the attraction of the electron. For choice D, specific heat capacity, great test taking tip. If you see an answer and it looks completely foreign to you and you're like, did I learn this? The answer is probably no. So on tests or quizzes or anything, don't go picking answers for things that we haven't talked about yet. Tests are not the time to start inventing new ways to do questions. Okay. Number 13. Number 13 says an atom of an element has a total of 12 electrons. An ion of the same element has 10 electrons. Which statement describes the charge and the radius of the ion? So there's a lot to unpack there. Answer choices look wordy. let's kind of break down the question first and then kind of have a better idea of what we're looking for. So it says an atom has 12 electrons and your ion has 10 electrons. So how do we get from 12 electrons to 10 electrons? You have to lose 2 electrons. Now remember, electrons are negative. If you're losing negative stuff, you become positive. Remember, positive ions are called cations because cats have paws, it's positive. So now we know that it is positive. So then if you're thinking about it, if you're losing electrons, are you going to get bigger or smaller if you're losing stuff? If you lose stuff, you get smaller. So the ion is smaller. So we're looking for a positive ion with a smaller radius. And if you go through all the answer choices very carefully, that is what A says. Ion is positive, radius is smaller. Okay. Moving forward, number 14 says, what is the total number of electrons in an Mg2 plus ion? So remember, magnesium normally, the atom. So magnesium has atomic number of 12. It has a mass of 4. So normally in an atom, it would have 12 electrons. Remember, protons equals electrons in an atom. But this 2 plus thing means something happened to the electrons. So if you're positive, if you have a positive sign, that means you lost electrons. And that number tells you the number of electrons. So if you're losing 2 electrons, 12 minus 2 gives you 10. That's 10 electrons. If you see, let's say, negative, a negative sign means you gained electrons. This is side note. And this would still tell you the number of electrons. So if it's positive, you lost electrons. If it's negative, you gained electrons. And then that number tells you how many electrons you either lost or gained. Okay. Number 15 says which atom has the largest atomic radius. So it gave you potassium K, rubidium Rb, cesium Cs, and francium Fr. So these all happen to be in group number 1. You have K, Rb, Cs, and Fr. So whenever you talk about atomic radius, you should be thinking snowman. And so as you go down, the AR increases. As you go left to right, the AR decreases. So which one has the largest atomic radius? Well, the lowest one down. That is francium. It is C. Another way to go about doing this is if you forget the snowman, if you forget the trend, go to table S. All table S has the values of each of these atomic radiuses, and you can still come to the same conclusion that francium has the biggest radius. Okay, so with question number 16 says which list consists of elements that have the most similar chemical properties. Whenever you see most similar chemical properties, that should shout to you the same group. Remember, group is column. So if you look and find these elements on your periodic table, again, guys, you need to use your periodic table. The unit is called the periodic table unit. So without your periodic table, some of these questions are like impossible. So you need your reference table. Okay, so if you look for all of these elements, the only group that has all 3 in the same group or same column is B, and that is the start of group 2. Okay. Number 17 says which grouping of circles, when considered in order from top to bottom, best represents the relative size of the atoms of Li, Na, K, and Rb, respectively. So if you were to look on your periodic table, you'll see Li is on top. followed by Na, and then K, and then Rb. Well, hey, look, they're going down a group. And again, whenever you think atomic radius, your first thing to do is draw that atomic radius snowman. So as you go down, remember, the atomic radius increases. And so the option that looks like a snowman, and this is why we draw the snowman, is choice A. So there's that. Again, if you were to forget the snowman, totally okay. Check table S, look at the values for the atomic radius for Li, Na, K, and Rb. You'll see that Na is bigger than Li, K is bigger than Na, Rb is bigger than K, following the same trend. Okay. Number 18 says, compared to a potassium atom, potassium ion has. So, potassium is K. K is a metal. K has the electron configuration 2-8-8-1. So remember, each element wants to have that full valence shell. Potassium does not. Neither do any elements except for the noble gases. So you can either lose electrons or gain electrons. Now, if we look at this electron configuration, it's easier for K to lose 1 electron than it is to gain 7. And that's what it's like with most of the metals. So metals will lose electrons. So say goodbye to that. Now, if you lose electrons, you form a positive ion. Remember, positive ions are called cations. Cats have it's positive. Now, if you're losing electrons, now we just completely lost a shell. You become smaller. So the answer for this has to be a smaller radius because it literally lost a shell. And now you can see, well, here, got yourself a full perfect valence shell. Potassium is now happy. Okay. Number 19 says an atom with the electron configuration 2-8-2 would most likely what? So again, if you look at this last shell, it doesn't matter what element it is, but if you care to know, it is magnesium. Again, that is a metal. But even if you didn't know that, would it be easier to lose 2 or to gain 6? The answer would be to lose 2 electrons. Again, if you lose electrons, you form a positive ion called a cation. And if you are positive and you've lost an electron shell, you become smaller. So the answer that makes the most sense here would be A, decrease in size and form a positive ion. Okay. Number 20, this is based on table S, which element has the highest electronegativity value. So here is your periodic table. Fluorine is the most electronegative atom. Fluorine belongs in group 17, so that is your answer. Now, group 18, those are your noble gases. They don't have electronegativity values because they don't want electrons because they already have a full valence shell. So you need to remember the highest electronegative atom is fluorine. That needs to go into your head, and that's how you would do number 20. Okay, so question number 21. 21 says, which statement describes the general trends in electronegativity and first ionization energy as the elements in period 3 are considered in order from Na to Cl. So here is your periodic table. Na is over here, Cl is over there, and we are going across a period. So remember, electronegativity and ionization energy, they do the same thing. So we can get rid of choices A and B. So your next thing to think of, okay, well, what happens? Chlorine is right below fluorine, and remember, fluorine is the most electronegative atom. So as you get closer and closer to it, ionization energy, electronegativity increases, so therefore ionization energy increases. Therefore, the answer is C. Again, if you forget this, you can go to table S, look at the values for each of these things for Na, look at it for Cl, and look to see how it differs, and then come to the same conclusion. Okay, number 22 says which group in the periodic table consists or contains elements that are all monoatomic gases at STP. Monoatomic means it does not bond with anything. And hey, they're gases. So that sounds just like the noble gases. Noble gases are group 18. That is answer choice D. Boom, you are done with that. Again, STP, we're not in our gas unit, doesn't matter. Number 23 says which characteristics both generally decrease when the elements in period 3 on the periodic table are considered in order from left to right. So here's a periodic table. We're going this way. So from all the other questions, we know that electronegativity increases when you go left to right. Ionization energy also increases. But what's different now, and if we think about the atomic radius, so it's another trend we talked about, if you have that snowman, as you go across, atomic radius decreases, and your metallic character also decreases because you're going towards the nonmetals, so your non-metallic character would increase. And so your two decreasing things are metallic character and atomic radius, and that is answer choice C. Okay, question number 24 says the atomic radius and the ionic radius for some group 1 and some group 17 elements are given in the table below. Absolutely to the right, but doesn't matter. All right, both the name and the charge of the particle that is gained by an F atom when the atom becomes an F minus ion. So if you're becoming an atom and now you are negative, remember we have 3 subatomic particles. If you change the number of protons, you change the element. If you change the number of neutrons, you form an isotope. Same element, different mass. Nowhere is the term isotope mentioned. But if you see the word ion, that's when we're talking about electrons. So there is the name of that particle. And then what is the charge of electrons? Electrons are negative. So remember, if you see a negative sign means you gain electrons. Now, if you can see, there's no number here. So no number equals 1, and that means that's the number of electrons gained. So here, so a negative 1 means you gained 1 electron. So all you needed for this answer was that. Electrons and negative. Now, if you only gave one or the other, if you only said negative, or if you only said electrons, we'd have to mark it wrong because you're not answering the question. Okay, very last question. Same beginning, the new part is explained in terms of electron shells, where the K plus ion is greater than the radius of the Na ion. So right off the bat, you could just say K plus has more energy shells than Na. So it's telling you K is bigger, Y in terms of energy shells, so without really knowing much chemistry, you can kind of make this guess. But if you wanted to know why, here's our K atom. Our K atom has the electron configuration 2-8-8-1. Our K ion, remember, loses that electron, becomes K equals 2-8-8. Now, for Na, the Na atom, is 2-8-1. And again, the ion will lose that, so it becomes 2-8. And here you can see Na ion has two electron shells, the K ion has 3 shells. Even with the atoms, Na has 3 shells, K atom has 4 shells. And that's also the snowman. As you go down the group, K and Na are in the same group. K is below it and has more energy shells. Again, if you didn't talk about the word energy shells in your answer, it would have to be marked wrong because you're not saying it. If you said K is bigger, well, okay, the question says that. You have to look at the question carefully and actually give it the answer it is asking for. So, that is it. The end of the review video. If you made it to the end, congratulations. It was a long one. Hope it was helpful. Next video will be the first lesson video of Unit 3A, which is called Bonding, Ionic, and Metallic. Bye!